I'm speaking slowly. Okay, so our next speaker is Rob Steenburgh from the NOAA Space Weather Prediction Center, and he will talk about how SDO data has been used in the Forecast Center. Take it away, Rob.
Okay, let's see if my screen shares.
Looks good.
Are you seeing it?
Yep, yeah. And I'm going to give you a 3-minute warning, Rob.
Okay, that's good. All right, so I'm going to talk about how SDO had an immediate impact on the forecast office in the Space Weather Prediction Center. And really, you know, I look back at this talk because I put it together a while ago and I made some changes, but it's interesting some of the things I gravitated towards. So what I'll do is I'll talk about the way we were, what we're doing now, and some pitfalls we experienced along the way, as well as some possibilities. And you can see the upper right corner here, that photograph is our earliest animations, where you had to swing your head really quickly to see the movement. But we've progressed from that. And you've got a 90s view of the forecast office down there on the bottom, and then upper left is where we are today. And you can see SDO occupies a prominent position in the forecast office. So that is part of our situational awareness display. All right, one of the first things I thought of, and I think it was interesting, but this is the thing that popped into my head. And you know, Katie in her talk just before showed some of these solar synoptic drawings, and I've got an individual, and that's probably Ken or Monty, working on one there. But we actually print out images from SDO and use those and a transparency to create these drawings. So none of it's digital yet. But in this case, what we had in the past were only observations from the Air Force and spot reports and drawings that would be sent to us initially by fax and then by email. And some ground-based observatories to work with, and SOHO. And the availability of that data changed dramatically when SDO got up there. Talk a little bit about flare forecasting. On the right is a table, and this, you can see the date there, it's from 1980, of the types of things that forecasters look for the potential for flares. And we take this into account when we're putting together our flare forecasts, which originate in the Macintosh classification. And then based on these types of things and history, we'll adjust the numbers accordingly. So what were we doing in the past? For our routine solar synoptic drawing, we'd get a magnetogram from Gong. And the things we'd look for include neutral line and polarity of the coronal holes and Mount Wilson classification. We'd look at H-alpha for a qualitative location and area for the sunspots and the Macintosh classification. We'd use the spot reports that I mentioned earlier and the Macintosh class assigned by the Air Force observatories. And then we'd use the SOHO EIT primarily for coronal hole boundaries. Now, the thing is, these images didn't all come in at the same time. There could be very big gaps, and it could be because an observatory was clouded out. It could be because we were in one of the blackout periods where we weren't getting any information from SOHO. And consequently, as a forecaster, one of the biggest challenges was just getting everything to line up. There was a lot of effort involved in, okay, if I have this particular magnetogram in H-alpha and I have this SOHO EIT image, but they're off by several hours. How do I draw the coronal hole? Where do I put that? And it was all a very primitive in terms of accomplishing that. That was always challenging. And I came to SWPC in 2007, so there are people with a lot more experience making that happen than me. But that I found always challenging in our day-to-day operations, was just getting the data in a way that we could easily assemble that synoptic drawing, because that synoptic drawing really is the process of creating that allows us to wrap our heads around what's going on at the sun and the potential various threats from space weather. So that's the exercise is really useful in that it forces you to look at all the data to try and understand it and put it in the right place. So it's actually a key element of the forecast. For flares and eruption, we look at XRS for flare thresholds. We try and eyeball SXI for the flare location. For a while, it would provide flare location, but later iterations of GOES did not. We'd also look at SOHO for flares and EIT waves if we had the imagery. And we'd use H alpha for filament liftoff. And then again, the Air Force ground-based observatories would provide flare reports and other information to us. But again, those Air Force reports were contingent on the observatories not being clouded out. So just as it can be kind of heartbreaking during campaigns when you're trying to capture something, it can also be heartbreaking day-to-day operations if you're really trying to get a handle on what the area of a particular region is, for instance. Okay, so now what happened? Well, you can see, putting together the solar synoptic drawing, now instead of hours to almost a day, we can get images within minutes of each other. And you can see the types of things that we look for in these images, similar to what we always look for. The coronal hole boundaries, I'll make a special mention there because Katie mentioned it earlier. What is a coronal hole and how do we decide where those boundaries are? This is particularly pertinent right now for me because we've been trying to work with the folks on operating the Discover spacecraft to capture a high-speed stream. And I think we're 0 for 2 right now because the stream has either failed to materialize because the coronal hole has changed from the time we planned the data gathering to the time it actually arrived where we thought it was going to be, or in some cases had vanished. So that's particularly pertinent right now. Spot reports. The spot reports that we got from the Air Force, and even today, that's where we get our quantitative location for these, and area and Macintosh class. But now we can also observe in near real time the evolution of these regions, and that's huge. And this is something that I was talking with Chris Balch about this yesterday, and I think that is the most phenomenal piece for us, is the temporal and spatial resolution, because now we can watch these things evolve in a way that we were never able to before. And we briefly had direct feeds from USAF observatories, but those weren't sustainable. The Air Force has a lot of network rules that made it impossible for us to get those images continuously. In any case, for flares and eruptions, we still use the XRS for our flare thresholds, but now we've got AIA for location and waves and filament liftoffs. And some of the, again, because of that spatial resolution, is just phenomenal. HMI, we can watch these regions evolve. And now, because we're not just getting snapshots every so often, but we're getting a continuous feed of this, right up until forecast time, we can adjust things and hone our forecast. Now we have GoSUVI as well. I haven't really gotten to use it too much operationally, but I'm excited that we have it. We still use Gong H Alpha for filament liftoff, and Gong is becoming operational now, an operational asset for us. So that's a huge step forward for us as well. And then finally, the Air Force reports are still critical. Right now, that's the only way that we have to estimate the area of the sunspots. So just a couple pitfalls. I got fooled. And you'll see my, I like alliteration. So I said the pulsating pustules of positive polarity turned out to be a processing problem. I had to alert the forecasters of this. And you can see the arrows there. So we had regions that were appearing as delta regions, and it turns out they weren't delta regions. It was just where things were getting saturated. And this to me was analogous to when I was doing meteorology full-time, velocity aliasing that we would see in the Doppler radar returns. The thing I'd like to draw your attention to in the upper right is notice those purple regions. Those are regions where the data has been flagged as suspect. And in retrospect, had I been laying out how we imagery in the forecast office, I would love to have a flag that shows me, hey, this particular thing is suspect. Because if you write about a delta type spot group that's not really a delta type spot group, that's not good.
Hey, Rob, you got 3 minutes.
Perfect. Right at the end. All right. So other things I'd mention, some possibilities. Continued education and training for forecasters. This is tough. It's tough because they work shifts. It's tough because we aren't always in the scientific literature. And even when we are, we have to be generalists. So we rely on the heliophysicist to help us take findings from research and incorporate those into operations. And without that bridge, all the good work that's being done doesn't make it into the forecast office. If I had time and abilities, I'd build tools to give me heliographic coordinates and area and extent, the types of things we receive from the Air Force. I'd love to be able to pull those out of the HMI data to be able to use in my solar region summaries. There was a lot of, when I first started really looking at this stuff, the patches, to me, I had a hope for something akin to a tornadic vortex signature or a mesocyclone alert that would say, hey, this region is particularly primed for a significant flare, or for us, particularly importantly, an eruption. That's huge. And I haven't, I haven't seen that make its way into operation. I don't yet have a flare signature that I can use to give me 20 minutes lead time on an X flare, for instance. And stealth and problem CMEs, that's the last one that really that's burned me before. And the key there is sometimes you can pick that stuff out, but the imagery has been really highly processed, way more than what we could do in the forecast office. Finding ways to get enhancements that would show us those things, I think would be fantastic. That's the end of my talk. I'd like to thank Dean and Barbara Thompson, who is always the person we end up calling if we don't get the imagery. But I have to applaud the SDO crew. You've been super responsive, given us great assistance. And even though this is not technically an operational asset, we've come to think of it as one. Todd Hoxman helped me solve the pulsating pixel puzzle. And so thanks to him for that. And then Doug and Chris and others at SWPC helped us make this work in operations. And it's just been huge. One other thing I didn't include in this talk, but Katie reminded me of is the Eve proxy for flares. Sometimes we have GOES outages, either for maintenance or different things that are happening. And we've used that successfully in operations to help us as well. So that's what I have. Thank you.
All right, thanks, Rob. We're running a little behind, but I'll ask one quick question. Does SWPC, do the forecasters use coronal dimmings to predict CMEs at all?
Absolutely. Absolutely. That's a huge thing. And having that, again, that cadence and resolution helps us pick those out.
All right. I think it's hard to tell from the chat what's conversation and what are specific questions for you. So we'll take those to the breakout at the end. And I think we'll move along so we stay closer to the time. And as I